Yes.
That, and then
Yes,
I'll
I
start
will,
the sharing again then.
Right, that'll go away shortly here.
Okay. Do you want me to share after the introduction, Stephen, or should I go ahead and?
You can leave it up. I
Yes.
don't think,
And
Yes,
then I'll
I
start
will,
the sharing again then.
Oops, sorry.
yeah, go ahead, and I would just say leave it up. There's no point in having to worry about whether you've got the right screen and all that kind of stuff up. If it's good now, leave it as is.
Okay.
Okay, so I'll go ahead and start this if you guys are ready.
Yeah.
Okay.
Hello to those of you who are very quick and punctual to join. I'm going to give folks another minute or two to filter in, resolve any tech difficulties, and then we will get started. So thank you for being here, and looking forward to it. Okay, let's go ahead and get started. Once again, thank you all for being here and for your attention and participation. Today we have with us Dr. Benjamin Defoe, who is a professor at St. Louis University in the Department of Earth and Atmospheric Sciences, who studies different ways to improve emissions inventories and a host of other things. And so he will be talking with us about climate change in particular. This is a pressing issue of our time. I want to quickly take a moment to thank our sponsors, UMSL Global, the Office of Global Studies and International Education at the University of Missouri St. Louis, and the World Affairs Council of St. Louis, which is a 501c3 nonpartisan nonprofit organization dedicated to connecting St. Louis with the world and the world with St. Louis and promoting global mindedness. With all of that said, these programs are only possible through the membership of the World Affairs Council of St. Louis, so please consider becoming a member today. With all of those introductions out of the way, I will turn it over to our esteemed guest, Dr. Benjamin Defoe. Thank you.
Okay, well, thank you very much, Dr. Bagwell, for the introduction. Thank you for hosting this event, and welcome to everybody to talk about climate change today. I'm glad to be here. I wonder if anybody recognizes this. Well, I gave it away here at the bottom. Lohmeyer Sculpture Park here in St. Louis. This is my favorite season in St. Louis. I've only been in St. Louis 17 years, so I'm fairly new to the area, but a beautiful tree, and it made me think of this quote from G.K. Chesterton. Fairy tales say that apples were golden only to refresh the forgotten moment when we found that they were green. They make rivers run with wine only to make us remember for one wild moment that they run with water. And I think one of the things as we talk about climate change is to remember, remember just how extraordinary the Earth is, and that, what are the things that we have in common and that we can agree on. And to ask, we would poll this if we were in person, where would you want to live? And nobody wants to live at Venus. It's got a huge greenhouse effect that ran totally out of control. All its oceans evaporated, and the temperature at the surface of Venus is lead would be molten at the surface. So that's a non-starter. I used to get occasionally students, one or two students who would want to go to Mars. I haven't recently, but maybe that's because we haven't done this as much. It's a long way away. It's pretty cold. It has a little bit of an atmosphere, not very much, a little bit of an ice cap. And so we see there in the middle, the Earth. The Earth is special because it has water in all three phases. You can see liquid water, you can see solid water, you can't see the vapor, but you can see the droplets of the clouds. And so this gives it this sort of the complicated hydrological cycle that we have. And so we want to sort of keep this in mind as we talk about climate change is that, like I said, the things that we agree upon, the things that we depend on. I sometimes ask people, when was the last time you said thank you for your first breath of fresh air as you get up in the morning? And when you look at this picture, sort of what do you see? You could do this as a little exercise. Ask yourself, what sort of things is this showing? I mean, one thing you could see is obviously the Sahara Desert right there, very dry. You could see the mid-latitude storms to the north of the Sahara Desert. So we sometimes like to complain about them here as we are in the mid-latitudes, and yet they bring us the water we need to live and to have this lush vegetation we're fortunate to have. South of the Sahara, you can see the African tropical rainforest, and you can see that thin band of clouds that marks the equator, the intertropical convergence zone. So you can, and that tells us how the winds are moving. They're moving together towards that band, holding that line. You could ask yourself, what time of year is it in this picture? It's the North Pole is lit, so we're probably in spring. It could be in fall. And what time of day it is. It looks like the sun is over the Atlantic, so it's probably sunrise in St. Louis. We're on the other side of the globe. The Earth turns like a right hand with your thumb pointing up and the fingers curling around. So all these things that we see, once we start looking in the surface, I really want to sort of drive that home a little bit, because that's kind of what science does, is to make things that are invisible visible, things that we do not normally see, we can see them. And one of the things actually that we see once you start studying all this is a new phrase. If people do not know it, I want you to learn it all. Mitakuye o yasin. You're all at home, so you can say it to yourself without fear of anybody looking at you. Mitakuye o yasin. It's a Lakota phrase that means everything is connected. And this is really one of the big lessons of environmental science. Which does mean that environmental science functions a little differently from some of the other sciences. Things like physics, chemistry, biology. Often you can constrain your experiment. You've got it all sitting on the lab. You get hopefully clean data, and it works. Atmospheric science, environmental science is a bit different, because we can't fit the Earth on a lab, and we only have one Earth, so we can't really do experiments. And so we're part of the experiments that we're in. And that changes, I think, the way the science is carried out. And it does sometimes lead to, people outside the field sort of making comments about atmospheric science. So the quote below is that, I think, from Einstein, like every quote from Einstein, that's somebody, we suffer from an optical delusion of our consciousness. We experience ourselves as separate from the rest. I think for us as Americans, it's especially maybe a good thing to keep in mind, to remember, sort of, we think we're related, but how long would we live without everything being connected? Good. So on that feature, getting more then towards the subject at hand today, making the invisible visible. And the Keeling curve here has, hopefully many of you have heard of the Keeling curve. Here's Chuck Keeling here with his measurements. It's on top of the Mauna Loa Observatory in Hawaii. It was in the news recently because Mauna Loa is an active volcano, and it blew up in November. So the observatory had to be relocated for a little bit, but it's back in operation. And what Chuck Keeling did was, in 1957, during the International Geophysical Year, convinced people that it would be worth measuring CO2 in the middle of the Pacific on top of a mountain. That the International Geophysical Year was, I think it's also kind of an interesting thing to remember, 1957 was an effort at the height of the Cold War, saying, why don't we try and do something where we can get scientists, maybe from Russia and the US, to work together to diffuse tension a little bit. It was a little bit of the science equivalent of the ping pong game in China. Let's just diffuse tension, get people working together. And so there's the time series from Mauna Loa starting in 57, and you can see CO2 concentrations going up and down. This was supposed to last 1 year, one cycle here, up and down. But by sheer strength of will and determination, Chuck Keeling was able to keep it going. I think he passed away around here in 2005, if I remember correctly. His son actually has taken over and does continuous measurements of CO2 and all sorts of other things. And you can see this rise. It just keeps on going here. So we can't see it when we look at our window, but you can see it very clearly when you measure things. You can also see these little wiggles go up and down, and that would be the Earth breathing. At the moment, the CO2 is rising. We're coming out of winter. Spring is there, but we're not yet in full production of oxygen. So plants are still putting out more CO2 than oxygen, and the CO2 concentration is going up. As summer comes along, summer in the Northern Hemisphere, most of the forests of the world are in the Northern Hemisphere, that they will draw down that CO2 and put out more oxygen, and so the CO2 will go down into the fall, and then it will start going up again. So we really see nature breathing here. There's one thing I want to show on this. Okay. Just go to the website. Hopefully you can see. This is the Keeling curve website at UCSD in San Diego, and so you can go to this. And you see the full record here, but you can toggle over the different timescales. And I think this is another sort of very important question for atmospheric science, maybe different from other sciences, to be thinking about things happening on multiple different timescales. So, here we have 80 years. We can go here to see over the 2-year timescale and see that variation of the seasons, the Earth breathing in and out. 1 year. You can see those blue data points here when the volcano erupted and there was a gap. It was like, oh, scramble, what do we do now? And then the instrument moved to the neighboring peak, 6 months. And when you look on the short time scale, you can see there's variation. There's always variations. It's alive. The Earth is alive. Things are changing, and you get these little peaks. These are probably actually volcanic CO2 coming in. You can go the other way. So now our measurements are over here, but this whole part is CO2 measured from different sources, from vegetation or from, we'll see in a second, from ice cores. For a long time, it was kind of stable, or it looks like it was constant. But in fact, when you go even further, 10,000 years or 800,000 years, you see that it actually varied on this time scale of every 100,000 years, going up and going down, varying between about 170 parts per million to 170 parts per million. So I encourage you to go check that out after the talk. Come back here to that. To see what is happening in the climate. We only have one Earth, and so our lab is really to be observing it as much as we can. And the Earth has kept a record of the CO2 over the million years. If you go to Antarctica, you drill in the ice, and these ice cores there have little bubbles of air in them. You extract the bubbles, and then you can measure the CO2 concentration. You extract isotopes, different isotopes of oxygen, of carbon, and you can estimate the average temperature of the Earth at the time, and you see it going up and down. The difference, I think, to set the scale here, the difference between 170 ppm of CO2 and 270 ppm of CO2 is roughly the difference between having a mile of ice on top of you if you live in Chicago, or no ice at all. So from there to there. Down here, we would have big ice sheets coming all the way down to St. Louis. We were kind of, for some ice ages, we were the edge of the ice age. That's why we're here, and having no ice. And we could see we're that much again out above what was kind of normal variations of that. We're outside the operating range. If your temperature does this, you don't pretend there's nothing wrong. You check yourself in the clinic, or if it's COVID, you stay carefully at home. And I think the other thing then to keep in mind for climate science is just how much extraordinary work is happening. This is an example that I thought was pretty interesting. I had never heard of this coccolithophores, So once you've mastered Mitakuye or Yasin, you can then learn coccolithophores and hopefully impress science-minded people. People have studied these little shell-like features, things at the bottom of the ocean, and have found that over the course of millions of years, their evolution was in fact connected to some of those ice ages and to the tiny changes in the Earth's orbit. And so I just thought it was a neat example of how everything is related and how these tiny things, tiny changes from the sun and from the orbit of the Earth can actually lead to all these different changes on Earth. And this might seem a little abstract, but there are, bigger changes that affect us directly. So that's all to do with CO2, with orbit. What do we know if we're looking at the temperature? We know that all the warmest years on record have been in the recent years. This is not news to anybody on this. And 2022 is also on track to be a pretty warm year. So again, if this is what your body temperature is doing, you know that there's a problem. So likewise, if this is what the Earth's temperature is doing, then we know that there's a problem because it's outside of that operating range of what happened in the past. We also want to know, like, one big thing in Earth science, because we don't have a lab, is attribution science and modeling, that we can use computer models to test our theories. And in a sense, we have to, just because we can't do it in any other way. And so one thing that we do is we have the black line is our observations of temperature increase. And you see temperatures have been increasing since about the 60s, okay, 50s, 60s. A clear increase, and it just keeps going up in a moment. And then we can build a model of the climate, and we put everything we know, all the natural factors we know in it, and we can kind of represent the variations in the climate here in blue. That's what we see. But we're not able to get that increase of the last 50, 60 years when we do that. However, if we then add human factors into our model, then we're actually able to represent that quite accurately. So we're able, and this is true not just for this limited time period, but people do models for the million years or even longer to try and represent changes in the past and to calibrate the model. So if somebody disagrees with them, I would say, the onus is on them to come up with their own model. You can't, it's okay to be a naysayer, it's fine. We need skeptics, science progresses by debate. This is all well and good. But at some point, everybody is free to make their own model and to come up with an alternative explanation. And so far, the models that work, the models that include human factors. Okay. So that's to do with modeling. We can move from modeling into statistics and attribution science, as I was mentioning here, which is, if I'm late, if you invite me to your party, you don't know me, I show up late, you don't, and I say, oh, it's traffic, blah, blah. You don't know if it really is traffic or if it's just me. If, however, you invite me a second time and I'm late again, you might start to think, well, maybe it's not traffic. So if I'm late every time, then you start thinking, okay, this is not traffic. This is not an external problem. This is an internal problem. This is you. So we have, in a sense, sciences at the same level. If a hurricane happens once, it's very hard to say, well, is it because of climate change or not? But once you start building up a statistical record, then you can start saying, well, how much of it really is due to climate change and how much of it really is due to natural variability. After all, sometimes people really are late from the traffic. How do we separate out those things? So this is a huge exploding area of science, lots of studies. And what we're seeing here from climate change, I think in the plot, when you look at severe heat events, and you find that most studies find that they were in fact more likely to occur due to climate change than not. For drought, same thing, although it's a little fuzzier, rain and flooding, because there have in fact always been drought and rain and flooding, but we do find that there's been more recently. And down here for storms, it's not clear. I mean, there is partly climate change and partly not. So this is all research that's ongoing. One of the issues also with science is, we do this sort of going backwards, and so people want to know, well, what about the heat wave or the cold snap that happened a week ago or 2 weeks ago? It's like, well, we don't know. We're going to wait a couple of years, by which time the press has lost interest. So that's that. One of the predictions, the long-standing predictions of climate change, had been an increase in extreme weather. And so I do want to sort of say this because here in St. Louis, we're particularly affected by the jet stream when you hear about it on TV. So normally, the Earth spins like a right hand, so following your fingers, and as it spins round, it's much warmer at the equator and colder at the pole. So the winds actually come together because the Earth is spinning. The winds come and they circle around and form this strong jet stream here. We're right underneath it, so depending on where the jet stream is, we can find ourselves in the cold or in the warm or in the hot air mass, and so that changes our weather rapidly. So if the jet stream is fairly stable, then we would expect slower changes and more kind of average conditions. With a wavier jet stream, then we have more Arctic air sort of intrusions into going south, and we have more warm air moving north. You can imagine, so wobbly jet streams can lead to both floods and droughts at the same time. It can lead to both cold and heat at the same time. And one of the things that happens with climate change is we're warming the North Pole a lot more than the equator. So we're reducing that forcing of the jet stream. We're weakening the jet stream. So you think of it as a slinky, you're holding your slinky like this. If it's nice and tight, then the waves kind of stay pretty constrained. They don't move as much. If you don't hold your slinky as tight, it starts to wobble a lot and the waves move more slowly. So that's what happens on the planetary scale. So you can have suddenly a big ice storm in Texas that you might not have had in the past. You can also have a big drought because if you're in that area here of hot weather and your jet stream just decides it's not going to move as much and just stay there for a while, for a month, instead of just passing through, then you're going to lead to drought. That's how the jet stream is kind of connected with climate change and to this question of more extremes. And, yes, actually more wet, more dry, more cold, more heat, they really are all the signs of climate change. One thing also with hurricanes, and I still use Hurricane Harvey, because it was such a beautiful example of a hurricane that stalled and intensified in the last day. So we've got your hurricane moving through. We know that the fuel for a hurricane is warm water at the surface. And what happened is right at the end, it intensified very strongly. And then it dumped, 2 feet of water on Houston, which was unprecedented. One thing that's interesting from the scientific perspective, actually, is that the year before Hurricane Harvey, one of the main hurricane scientists in the world, Kerry Emanuel, published a paper looking at what would climate change do to hurricanes. And he ran a model for the next 100 years and said, well, look, in my model that I ran for 100 years, I simulated all these different hurricanes, and here's one from 2086. And what my hypothetical 2086 hurricane does is to rapidly intensify. Hey, this red, it stays blue through the Gulf of Mexico, and then at the end just becomes really intense. And we're likely to get more of it. So rapid intensification has become a thing now. We've seen it time and again with hurricanes. So this is a prediction of climate change that is coming true, and where we realize how vulnerable we are to, for nature, before, I mean, without humans, what difference does it make? 12 inches or 18 inches of water, and yet for us, it's a massive difference. So that's something to keep in mind. So just a little summary so far then. The greenhouse effect on Earth makes life possible as we know it. So everybody's on board with that. But too much of a good thing can destabilize the climate we depend on. We use computer models to study the changing climate and to use it as a lab to see what could happen in the future. And we have seen more extreme weather, and that's been a long-standing prediction of climate science. So I think we'll just have one question and answer session at the end. I just want to have the second part of the talk then with, just shortly, what are the things that we need to do for climate change? You know, it's not all doom and gloom. We've had problems in the past and we have solved them. And so what the kind of framework I want to present you with today is the three different types of actions: personal, societal, and vision. I won't do a great juggling act here. I've given talks for Christian groups and for Buddhist groups and for Muslim groups, and of course, sort of agnostic groups or just anybody groups. And there is a kind of a sort of confluence of thinking on this: the personal actions, societal actions, and vision actions. And we shouldn't be, I guess my big message is we shouldn't be fighting about whether it's one or the other. It's all three. But there are plenty of personal actions we can take, and that we probably are doing already. These have become much easier to do recently with the technology change, improved lighting, improved thermostats. Our diet is a big source of carbon, and there's plenty of things we can do. People talk about meatless Mondays, fish fry on Friday, fish fry, or, you know, all sorts of things we can do to reduce our footprint that would also improve our health, reduce our expenses, and lead to sort of better world overall. So we don't need to do things just for one reason. We can do them for multiple reasons. Hey, this was a while ago when my youngest daughter was still little. I like to, you know, I particularly like to bike, so that works well. Some people might walk. I think with the pandemic, we have seen a bit of an increase in biking and walking. But this connects then to societal changes, because you can't, you know, you're kind of constrained in getting around by the environment you built, the built environment around you. And so you can only go so far with private actions. You need to sort of think about your societal actions. Okay, this is actually a pedestrian town. This is where my parents live in Belgium. It's a university town that is entirely pedestrian. The cars here, they come in on this road and then they go underneath, and there's like an underneath parking lot here. So when you walk around here, you don't even realize there are cars, so that you could come by car, and everybody walks, and it's just great to live in, and you don't need to be an environmentalist to you know, to enjoy it. In fact, it's becoming kind of a victim of its own success as the prices go through the roof. And we've seen that with sort of well thought out cities around the US. Sort of. And we know that these kind of long-term societal actions lead to positive environmental actions, because we've done it. You know, people, hopefully you've all seen bald eagles in the wild. You take a trip to the river if you haven't, and observe them, the majestic birds who are on the brink of extinction. You know, science is able to detect something that we can see, DDT, make the connection to, you know, sort of fragile eggshells and the crushing of the eggs, and then sort of banning the substance. And now we have, so this is a big success of the required societal actions. You can't get there with personal action. There's a very good book here, Designing Climate Solutions. You can get the Cliff Notes version. There's a Vox.com interview of Hal Harvey where he kind of explains all these different things that make sense in society. And you can see that for now already in terms of energy generation, solar panels and wind energy are some of the most effective things. I do want to advertise this. This is an article from the Carnegie Endowment for International Peace that's spreading instability in oil-producing countries. The oil curve, and so many black areas on the curve. This really struck me, you know, with the Russian invasion of Ukraine, and so where this orange sort of turned into this massive red mass here of active conflict that's sort of financed by fossil fuels, and this kind of how many places of the world these. I mean, even Sudan at the moment had gotten out of the black, actually, and now it's back in the black. So my diagram is accurate again. Yemen, here, sort of conflict caused by oil, and how we don't do things just for one reason. We can do good policies for multiple reasons, not just because climate change. Sometimes I feel like, well, we don't even need to talk about climate change. We could do these things for all the other reasons. So one of the things that makes it hard is in the system, in a societal system, it's complicated. And so the other thing you can do after the talk is you can type En-ROADS here into your browser and go look at this simulator. And you can try different strategies down here and see what impact they have on our greenhouse gas emissions and on expected temperature rise in the Earth. So you do all these sliders, say, there's a little explanation, and then you can see, well, what is my proposed policy? So people do this. I do this in a classroom as a game. Different people take different roles, and yeah, and there's actually a lot of good ways of addressing climate change, but that do require sort of societal action. The last thing I think not to dismiss is the vision part, and you remember Martin Luther King started his big speech, I have a dream. I have a dream. That is, I think sometimes we forget as environmentalists, especially, sometimes people have all these doom articles about how we don't need humans anyway, or it would be better if humans went extinct. Well, what is the creative power of the human person? What is our vision of the good life? And this actually connects to a big gap in the English language. Hey, there's nothing that we really say at the beginning of meals to each other. Most cultures say, I'm from Belgium, we say bon appetit or bon provecho, or say something. And part of that, I think, connects with the personal action, but the societal action. Once we start looking at things differently, other actions kind of follow in that. The Japanese say itadakimasu, which seems to me very interdenominational. You could anybody can take it on. You don't have to be any particular creed. Itadakimasu means I receive, or I humbly receive. So, but to be thinking about that, sort of what is the goal of my life? Because it's not enough to just kind of fiddle around with my little carbon footprint, or write, all those things are good, or sort of do things with society, those things are good, but we also need to think about, well, what is the direction we're heading? So with that, I would like to leave you with this illustration here. The little Buddhist poet, the dewdrop world is but a dewdrop world, and yet to hopefully go forth in hope that there are in fact lots of things that we can be doing, there are lots of things that are happening, and to be looking for those positive developments. So thank you.
Thank you for that really informative talk. I'm going to abuse my moderator privileges while we wait on a few more questions to come in and ask the first question. When we're talking about policy prescriptions, one thing that we've really seen, I think, gather a lot of momentum over the past, 5 to 10 years, are these sort of big corporate net zero by 2030, net zero by 2050 type pledges. And I guess from your perspective, does the net zero type pledge even really make sense? Is this something that really is a net zero and is going to be an effective mitigation strategy? Or is this all just sort of for show, even if they do what they say they're going to do?
Yeah, this is a big debate. Is it greenwashing or is it for real? I hope I'm not being kind of hopelessly naive, but I feel like no. I think we need to get on the path. The first step, is important. The lessons of the past for environmental issues is that it's pretty much always been cheaper and easier to fix environmental problems than people thought. So we're now in St. Louis, we have pretty clean air. We're fortunate. Even under the very cold winter days, the sky is blue. This is not the case 100 years ago. It was black with soot. So I think it's good. I think it's good to have metrics. I think it's good to have targets and to get people sort of thinking about that, and in a way that everybody is feeling concerned, not just environmentalists. So yeah.
Great response. Thank you. We have a question from the audience. Krista Wolf asks, to what is the variation of the CO2 content attributed to before sort of modern times?
So if like here, you're saying, so before modern times, we had the natural cycle. So the Earth rotates, and it wobbles a little bit. It's like a spinning top. It wobbles, it rotates. and it's like this, and its inclination also changes. Sometimes it's a little bit more at an angle, sometimes less, and its orbit is sometimes circular, sometimes a little more elliptic. So all these changes are happening, and together they make a change in, I think we've determined that what matters is how much heating there is in the summer at the pole, because that determines how much ice is melts. And so that leads to the ice ages. And then there are feedback cycles between the ice ages and sort of vegetation productivity, that as the ice ages, as the ice sheets expand, you get less oxygen produced, less vegetation, so CO2, let's see, so CO2 will go up, and then we pull out of the ice age, and then there's too much vegetation, so now CO2 drops because all this vegetation is growing, and then we kind of go back and forth in this cycle.
Okay, thank you. Another question I had is reversal something that's even possible? And if so, sort of what does the scale of that look like? Is it, from a policy perspective or a politics perspective, one of the things we hear sort of developing countries say all the time is, well, the US has been polluting and industrializing for 150 years, give or take. They're really responsible for the carbon that's stored in the atmosphere at this point. We want the same economic benefits that the Americans have had for the past 100+ years. What you're not going to let us achieve that and improve our own people's lives if you hold us to sort of these climate pledges and really start to care about this issue only now. So is reversal possible, and I guess sort of how would reversal be possible? And then maybe if you've got thoughts on the politics of that big three-part question that you could probably do a separate talk on, but yeah.
Right, yeah, this is a big question, and people talk about the point of no return, the tipping point, and definitely the longer you wait, the harder it is to solve a problem. This is just a general life lesson that I think we're supposed to learn in kindergarten. Apparently, it's a lifelong process. So we're definitely getting to this point where we're not going back to how things were anytime soon. We've kind of baked in at least 2 degrees Celsius of warming, possibly more, and we will see, catastrophes happening, things like that. But that doesn't mean that we can't do something. And again, the time and again in the past, the ozone crisis, the acid rain, I think of all these as our practice problems, leaded gasoline, all these things that we solve. With respect to developing countries, I think sometimes, with the development of technology, there is this question of leapfrogging, and they say, well, just because we developed in this kind of dirty way doesn't mean that you have to as well. But maybe you could do away with this, and you would be better off for yourself. Sort of forget about us. With solar panels, with wind energy, plenty of things that can be done now that do not sort of follow the same path. And in the same way that, in fact, some countries are not even building landlines, for example, for phones. Just like we don't need landlines. Somebody could come along and say, oh, well, you developed with landlines, so now we have to develop with landlines. This would be stupid. So we sort of call out things like that. There is also, though, this unfortunate situation, which is that, who is vulnerable, and vulnerability is really connected to poverty often. So that's true in our own country, who is vulnerable to environmental issues, and we're really looking more and more at environmental justice. And worldwide, that it's poor people who will suffer more from this than rich people. So on the one hand, we need to somehow motivate rich people to act on, even if it's on behalf of others, and to sort of get this sense of, oh, we are in fact connected. And I think that was one of the lessons of the pandemic. For pre-pandemic, you could say, oh, well, I'm just doing my own little thing in my corner, and all of a sudden with the pandemic, you're like, no, actually, what we do matters. around the world. And also we depend on these things that we didn't know existed. All the essential workers. Why are all the essential workers on minimum wage when they're essential? What's the, that's a kind of a rambling musings, but
That was a very good response to a very complex and overthought question. So thank you for that. We have a related question from the audience. You kind of hinted at this at the end of your previous response, but are individual countries sort of changes towards sustainability, their efforts to reduce their carbon footprint at the sort of societal level, are those going to help restore the negative consequences of the past 100 years? Or is it going to take really a global collective type of change?
Yeah, I mean, it's, when people study common public goods in the world, and there are different types of public goods, and climate change is an aggregate effort public good. That means it's a public good where everybody needs to do something. Developing the vaccine for the coronavirus was the best effort public good. It was enough that one company developed the vaccine and then did it for everybody. You didn't need everybody to work on their own vaccine in their own house, fortunately. Yeah, so everybody, I think, needs to do something, but then that leads into the trap of saying, well, I don't want to do something if somebody else doesn't. And I think that's why it's so important to have these international conferences, even though they can be, frustratingly slow or things, but it brings people together, and we have to build this kind of momentum, but also we have to have people who are going to show leadership and move forward faster than others, and there will be laggards. And when the first people to adopt cell phones, cell phones are like these shoebox type contraptions that didn't work half the time, and now everybody's got a cell phone. So you're always going to have early adopters and laggards. So I think it's the same here. But we're seeing, I'm hoping, like with electric cars, for example, these are great. We had to change our car, so we got a Nissan Leaf. It's great, and all the kids are fighting to drive it. So we're getting to that point where there's definitely things we can do, and sort of looking forward, looking to the future.
Great, thank you. Another question from the audience from Seth Kilmer. Can you expand on aspects of climate change that lead to rapid intensification? Okay,
for the hurricanes. So I am not a hurricane expert, but I do know this, that, the fuel of the hurricanes is the warm water from the Gulf. And so the warmer the water in the Gulf, the more storms you're going to have, and more evaporation, that latent heat going into the storm. That's one factor. The other factor is the shear in the atmosphere, by which we mean the difference in speed between different levels. If the winds are faster above than below, then it can kind of tear a storm apart. But if the winds weaken everywhere, which could happen as a result of climate change, weaker winds, then all of a sudden the storm moves more slowly and does not get kind of sheared away. And so that contributes to rapid intensification as well. So there's all these different factors coming together, which is why you can begin to see how it's important to try and be studying these in the lab, or to have a hurricane. There are these planes that fly through the hurricane to do the measurements, and then to sort of build up a database of past examples and to be studying them.
Thank you. One more question. You might need to go back to the slide for me, but you were showing, I think, climate change or average temperature in the past, since like 1900. I remember talking to people slightly older than me who are in some ways still convinced that climate change is not real, and that this is just people getting things wrong, because in the 60s everybody was worried about global cooling instead of global warming, and so this is just another like big overreaction. And I'm wondering if there is a good explanation that I can tell people, hey, this is why global cooling was happening in the 60s, this downturn, And this is why we should be really concerned about warming now.
Yeah, it's a bit of a specious argument. So I really liked the climatologist Catherine Hayhoe, who's in Texas and gives a lot of talks on climate change, and she has a book, Saving Us. And so one of the things she says is you're not going to convince a climate skeptic by talking to them about science, because you can have an hour-long conversation, they'll remember the 5 things that support their own views, and you will have wasted your time. But that's not to say you should not interact with people. We're in a democracy. We actually need to be talking to each other more, not less. So instead of talking to them about climate change, she suggests, engage with them on some other thing. I mean, we're all human. We got to have something in common that we can talk about and engage that way. And then maybe at some point, once you've built rapport, you can kind of, and this will take time, but you can then sort of get to a conversation more about, well, what is happening? I mean, this question of the 60s, I think it's more related to the way the media works than to the way the climate works and to the way disinformation works. Are you listening to a media source that only tells you what you want to hear, or are you listening to a media source that is telling you real information? How would you know the difference? But there's all these sort of, it's all connected. so I really take that lesson to heart. With I do this. Like airplane rides are actually kind of a good way to interact with people because they're captive. A professor always loves a captive audience. But I've had interactions like that with people who were, opposed to climate change, but we kind of talk about what matters, and we find that actually we do find common things that we care about, and not everybody has to do everything, but I do think because it's an aggregate effort, public good, everybody has to do something.
Thank you. Another question from the audience. What are some global examples we could look to for inspiration on sustainable solutions that are successful? Whether that's urban development or I believe you mentioned sort of electric vehicles. What are some big initiatives that you've seen that you think are successful and could make a really big impact?
To think if there's a news source. I mean, part of me feels like, everything. When you look at solar energy development, wind farms, you look at, I mean, even in the US, carbon footprint has in fact reduced. In Europe, it's reduced even more. Yeah. I feel like I'm a student stuck on my test right now. So there should be, one thing that's good. There's a Drawdown. It's a book that has, I think it has like 100 different things that really made a difference. Project Drawdown. You can look it up, and it's true. I get books to sort of media, but it sort of highlights some of these things that have made a big change.
I will definitely look that up. This is another big complex question. I'm a political scientist. These are the only types of questions we like to ask people. So I apologize for that in advance. What sort of advice would you give to a society or a government that was in an area where they were going to be immediately impacted by climate change? So I'm thinking of smaller Pacific Island countries where, global warming 1 degree Celsius is going to lead to a certain amount of sea level rise. And there's only so much you can do when you don't have the giant landmass that like the US has, that you can just move further inland or, do other things like that. So if you were going to give advice to policymakers in those countries on how to mitigate what is likely, I believe you said a 1 degree Celsius increase is pretty much inevitable at this point.
Mm-hmm.
So what would your advice be on the best ways to mitigate that?
Well, I think we need to remember nature is powerful. and we ignore nature at our own peril. And we have a tendency to do this. We think we're invulnerable. We're kind of like teenagers, eternal teenagers, where we think we can sort of not worry about things and not listen to scientists who are a pain in the ass. So, I mean, even remember the early days of COVID, it's like, oh, it will go away. So we need to remember that nature is powerful. And I mean, there are things we can do, to sort of adapt to climate change, but some places you will not be able to adapt. I study air pollution. I was in Bangladesh. There's a lot of areas that profound risk of flooding, and the other sort of human fault, in a sense, our brains that sort of put our head, the ostrich reaction to put our head in the sand over these big, when a problem seems too big, we're like, okay, well, maybe the problem will go away, and this problem is not going to go away. So I think it will. This goes back to the briefing. This question of migration. There will be movements of people. There have always been movements of people. So we don't need to be kind of alarmist, but we do need to think about how different places will become habitable or inhabitable as a result of this.
Excellent, thank you. One question from the audience, Carolyn Goldsby. Excuse me, how could scientific modeling be better utilized in policy development? And is this even a useful question, seeing as scientists have been sounding the alarm for years about the need for climate solutions?
Yeah, I mean, I think people talked a lot about how models are wrong. Models could be wrong, and what we're seeing now is that and scientists have long said, well, all models are wrong, but some models are useful. That's really the question to ask: is how useful is my model? What we're seeing now is it's possible. People thought the models were wrong to predict climate change. It's actually possible that the models were wrong in not predicting enough climate change. That the models are wrong the other way from what people thought. So I think, I mean, I do think sometimes the models are able to make things visible. At the moment, there's kind of, I think, an extra focus on data mining, machine learning, statistics, all these things, which is a little bit away from models and more into kind of visualizing the data, which I think is a good way of moving forward, especially with there are new satellites being put up all the time, observing the Earth and sort of having a better observation of the Earth, making maps available just so people can see it in a way that, once we saw the ozone hole, then people started saying, okay, we really need to do something. Because, with these small changes, we don't necessarily see it. I mean, a 1 degree Celsius warming, in St. Louis can change by 20 degrees on a single day or more. So we do need, I do think science has a role in making things visible to people, but it's not, until people kind of really feel it, I think it will not be enough to do the model. The other thing then is the other kind of modeling, I think, connects to the En-ROADS model that I was showing you at the end, is how do we connect the physical science model with kind of human activity models and economic models. I think there's a lot of growth there and a lot of potential there to say, well, look, there are solutions there that are doable and that we can go forward. This was done, there's a bigger effort in this that was actually done to help policymakers, when they go to the IPCC conference, to say, well, what really matters? What is it that we really want to argue about? Or, you actually can get 2 degrees without putting any price on carbon and without hassling the coal industry at all. And, maybe that's something to focus on. And instead of focusing on those, we'll just shift and say, what are the problems we can solve? So I think models have a role there in terms of simulating different strategies, all these kind of complex interactions, and choosing better policies.
I think it's a fantastic answer. We've got time for maybe one more question, and then I will hand it over to you to get any major takeaways, things like that, after this next question. It seems like, and I'm going to oversimplify here a little bit, humanity, the evolution of human society has been, to some degree, just moving from one crisis to the next. And putting out one fire by starting a flood, or something along those lines. You can just kind of see, okay, we see this climate crisis, so now we're creating a bunch of nuclear waste because we've relied on nuclear energy, and that's an over embellishment for this specific case, but it seems like there's been a number of instances like that. Now we have electric batteries that we don't know how to dispose of because the chemicals used in them are toxic, right? All these sorts of things. And I'm a believer personally that it's best to solve the current crisis and figure out the next crisis later, because the current crisis will kill you before the next crisis will. So, I'm not saying this as a skeptic in any way, shape, or form, but I'm wondering if you can talk a little bit about how do we ideally move to a situation where we do not create new problems by solving the current one. Is there a way to do that? Do you have any sort of insight on that?
Well, I think it's good to remember that we have problems, but things have gotten a lot better. Look at I mean, like I was talking about diet, for example. There's a lot fewer stomach cancer cases now than there were in the past because actually a lot of it is government regulations of food, quality of food, refrigeration of food, and additives to food. So, and part of it is, I think, sometimes I think humans, we're kind of like our own immune system. Our immune system likes to have things to deal with. And when we deprive our immune system of things to deal with, then it kind of goes into overdrive and we develop allergies and all sorts of problems. So, so we kind of need to have problems. There will always be problems. But, as we go forward, that we do find that things have, in fact, improved a lot. I mean, the battery, it's true. I mean, electric cars, I mean, this is a massive shift. So it will require a societal shift. And we don't yet know how to recycle those batteries most effectively. But people are working on it, and that's really the lesson, I think, from past environmental actions is once you unleash innovation and creativity, the costs come down and the effectiveness goes up. And people did not want to phase out chlorofluorocarbons, for example, because of the at the time, the ozone hole crisis. Oh, it's too expensive. You're just kind of communist, anti-capitalist, blah blah, whatever. This is not true. We're all living pretty comfortably. We have air conditioning. We have all these things, and we phased out PFCs. So yes, there are problems, and yes, we need to address them, and yes, we need to pay attention to those. But also, yes, things are in fact getting better.
Thank you. That was a wonderful response. One last question, if you want to weave this into the last word, the big takeaways, anything else like that when I hand it back over to you. Can you recommend further books on the subject? You've mentioned a couple throughout your talk. Have Krista Wolf here in the audience who's interested in learning even more.
Yeah, I mean, what did I say? Catherine Hayhoe Saving Us, so the Project Drawdown, the designing climate solutions. True, there are a lot of books at all different levels. You could email me if you, depending on your things. I'm not sure I can think of any. It's a little dated now, but there was a good book, The Discovery of Global Warming, which I thought was interesting because it kind of showed science as a process and a development, So, but that won't give you the latest up to date. There are other books that will give you the latest up to date. But I would, I guess I'm more hopeful now. I think we're seeing. I mean, it's a scary time because we are seeing, with the wildfires, for example, with the droughts, we're seeing a lot of scary impacts with pests, mosquitoes spreading, but we're also seeing the seeds of growth and the seeds of solutions. And I think especially people who want to change, to go back to this, and maybe to hear your feedback on it, at other occasions, focus that sort of thinking about personal actions, societal actions, and your vision, and not to get stuck in sterile debate. We don't need to argue about should we do one or the other, because in fact, we kind of need to do all three. Even if you want to focus really on societal actions, which I think is probably the one good place to go, you still need to be doing personal action so that people will believe you as a kind of personal witness. So that would be my parting words. So thank you for your attention and your question.
Thank you so much for your thoughtful responses and your really informative talk. I learned a lot. I have no doubt our audience did as well. Audience, thank you for being here. Thank you for your questions and your attendance, participation, and attention. As a quick reminder, our sponsors are UMSL Global and the World Affairs Council of St. Louis. And these programs are only possible through the membership of the World Affairs Council at St. Louis. So please consider becoming a member today. Our next event will be on China next week at the same time, same place. So again, Dr. Dufour, thank you so much for your time and your preparation and your thoughtfulness in engaging with all of these.
Thank you.